So I realized after looking at the Delta math that you're going to need one more Edpuzzle in order to help you figure out how to do this unit circle calculations, okay? So we're actually going to step out into what's called trigonometric identities, and you're going to learn the first and most important identity for trig with this Edpuzzle, okay? So using the Pythagorean identity, instead of using x, we're going to use t, and you'll see why here in a minute. We can take the sine t squared plus cosine t squared and set that equal to 1. Okay? Remember that your cosine is the x values and your sine are the y values. So we can actually call this x squared plus y squared equals 1. Because of Pythagorean theorem identity, sine and cosine have bounds, okay? And so for all real numbers t, okay, your sine is between negative 1 and 1, and so is your cosine between negative 1 and 1. So the cosine function is what we call an even function because for all real numbers t, even if it's negative, you're going to wind up with a positive cosine. The cosine of the angles in quadrant 1 and quadrant 2 are the same and they become positive. The sine function is odd though for all real numbers t. If you have a sign that is a negative radians or degrees, the negative winds up coming out, and the sign of a negative angle is opposite of the negative angle. All right, we're going to take a look at this. This is t. You can also think of it as your y values, okay? So the y values we have are 1, pi over 2, 2, 3, and pi. And then we're going to go negative as well. And then that means that right here in the middle, there's your x-axis. You can think of it this way. And then notice that we're putting the 1, 0 for 0 degrees or 2 pi, 0, 1 for 90 degrees, and pi over 2, the negative 1, 0 for pi or 180, and then 0, negative 1 for 270, okay? So we have those going around. Okay, so if we look at the actual value of t, notice where number 1 would be placed on the unit circle. And then, of course, pi over 2 would be at the coordinate 0, 1. Then notice what happens with your real number 2. You know, it's somewhere in the second quadrant. And same with 3, right before your pi. Then with your negative numbers, notice that they are in the fourth quadrant, and then for negative 1, and then negative 2 and negative 3 is in the third quadrant. Alrighty. So this diagram helps show that radian measure are numbers that are on the circle with a radius of 1. Notice where the numbers 1, 2, 3, and negative 1, negative 2, negative 3 fall on the circle. Okay, notice that these numbers are different than the coordinates. All right. So the equation of the unit circle is x squared plus y squared equals 1. Now remember that is the equation of a circle, right? Except the origin is like 0, 0. Okay, so notice the domain is negative 1 to 1. Your sine t, remember, is equal to the y values, and the cosine t is equal to the x values, okay? And so our new ordered pairs are often from the form pt is equal to cosine t, comma, sine t. Just remember that the cosine t is equal to x and the sine t is equal to y. So one other brief thing, a periodic function is a function that repeats the same thing over and over again. And so trigonometric functions are periodic because they repeat. And your sine and cosine functions have a period of 2 pi. Okay. From your unit circle, you can see that the ordered pairs on your unit circle do not begin to repeat until after one complete revolution of the unit circle of 360. Remember, 360 is also 2 pi. Also keep in mind your reference numbers. We went over reference numbers. So for any real number t, the reference number r, we can call it that, associated with t is the shortest distance along the unit circle from t to the x-axis. So remember, your reference numbers always always have a relationship with the x-axis. Therefore, the number r is always in the interval between 0 and pi over 2, in other words, 0 and 90 degrees, which is the first quadrant. So if you look at this one, what is the reference circle number of 13 pi over 6? Well, if you subtract the 2 pi, in other words, 12 pi over 6, notice that you're going to get a pi over 6. So their reference angle is 30 degrees, and in this case, it happens to be in quadrant 1. All right, so what does that mean for our delta math examples? Okay, so notice here's our point P. We have an x. We're looking for the x. Remember, this is the y value. Now, these really aren't that bad because we're going to use the x squared plus y squared, the trig identity, and that's going to be equal to 1. We don't know what the x squared is, but we are going to be able to find it because we know what the y is. And so we're just going to take our y value and plug it into the equation and square it. Okay? So we're going to wind up with x squared plus 3 over 4. Okay? And that means that this just becomes a very simple multi-step problem. Okay? Remember that you need to change the 1 to fractions, and in this case it's going to be 4 over 4, right? Because remember, you have to go with the denominator, okay? So we're going to get x squared is equal to 1/4, because 4/4 minus 3/4 is 1/4. Now we have to take the square root of both sides, and so x is going to be equal to 1/2. Okay, which makes perfect sense. Okay, so this is going to be 1/2, and then the square root of 3 over 2, which if you look at this should look like your 60-degree angle. See that? All right, so that is your basic example, and you might have been able to answer this just using your unit circle. But what if we don't have one of the numbers here that we need? Notice that this is in quadrant 2, okay? And you have to keep track of your quadrants because you have to keep track of whether your x and y's are negative. So again, we're going to come back to our trig identity, believe it or not. Okay, equals 1. Remember, that would be cosine squared plus sine squared equals 1. I'm going to plug in the negative square root of 8 over 3. And remember, that does have to be squared plus the y squared, and that's going to be equal to 1. Okay, I'm going to square this, and we're going to get 8 over 9. Remember, the negative is going to vanish, and then we're going to get plus y squared. And I'm going to change up my 1 to be 9 over 9. That's still 1, but it works with the fraction that I now have. So I'm going to subtract 8/9 from both sides. Okay. And notice how my y squared is going to be equal to 1 over 9. Remember to take the square root of both sides. And so in this case, I'm going to have y is equal to 1/3. All right. And so your y would be equal to 1/3. And so for these exercises, that's all you're doing is taking either the x value or the y value, squaring it, subtracting it from 1, and then again, pay attention to what quadrant you are in and whether your x or y is going to be positive or negative. All right, let's look at our last example because this is a little more difficult, okay? And they want you, I'm going to try and draw what they're looking at. And they say that the sine is a negative 33 over 65 and the angle terminates in quadrant 4. So we're going to draw ourselves a quadrant 4, okay? And they're saying that it goes around and terminates into quadrant 4, okay? And they want to know what the value of tan theta is. Well, we know that the 65 is going to be the hypotenuse, okay? We also know that the 33 is actually going to be negative 33 because in the fourth quadrant, your y values are negative, okay? Now you need to remember, so the side that we need to find is our x side, okay? And we need to remember the Pythagorean theorem. That's why they mentioned the Pythagorean theorem earlier, is because we have a squared plus b squared is equal to c squared. So we're looking for a squared, and it's going to be the negative 33 squared, and that's going to be equal to then 65 squared. All right, so what are our numbers? Our numbers are going to wind up being 1,089, and that's going to be equal to 4,025. Again, this turns into a simple multi-step formula as we subtract the 1,089 from each side. Okay, so that means that the a squared is going to be equal to 3,136. Take the square root of each side, okay? And that means that my a is equal to 56. Well, if my a is equal to 56, then the neat thing is we can now find the tangent, because remember, tangent is equal to your y value over your x value. And we can see that the y value is the negative 33. Yes, the tangent in the fourth quadrant is always negative. And the x value now is 56. Okay? And that would be what your tangent of theta is for this problem. Alrighty? So these are the two types of problems that you'll really be working with based off of the unit circle. Alrighty, thank you for your participation, and the end.